Hello, welcome to Probable Magic. Today I'm kicking off my other plan series, Drawing on Probability. This is episode 1, and we're going to be creating a probability of draw table. Now, in this series, I am planning on looking at using probability to examine deck construction. I'm not an expert in deck construction by any shakes of the imagination, but I like probability and I like math and Excel, and we're going to see what we can do. Also in this series, I'm planning on trying to create some tools in real time, making this one part magic, one part probability discussion, and one part Excel tutorial. So let's dive in and we will talk about some different things as we go. Going to create a new tab. Now, as I said, we are creating a probability of draw table. What that is a table that's going to show the probability that we draw a card of type A being a placeholder for whatever we're interested in on a given turn. Now, I've been playing a lot of limited. I think in limited terms, so I'm going to be doing this in the context of a 40 card deck, but you can just as easily do it with a 60 card deck. So for this exercise, we are going to be viewing our deck through the lens of consisting of two things: cards that are type A and cards that are not type A. A and not A are mutually exclusive, meaning any given card cannot be both A and not A. And A can be anything we want. For this exercise, I'm going to be using A to mean lands. So my deck will consist of lands and not lands, where not lands are often also called spells. We could, and later on in the series, we'll be looking at other things, such as A could be 2-drop creatures, and my deck consists of 2-drop creatures and not 2-drop creatures. A could be a single specific card, like Angel of Thune, and my deck consists of Angel of Thune and not Angel of Thune, and you get the idea. But tonight we are going to be looking at our deck consisting of lands and not lands, or spells. We're going to be doing this in the context of let's make this a little bigger for you, in the context of a 40 card limited deck, and we're going to assume 17 lands and 23 spells. Deck equals land plus spells. 40 cards. Okay. So, draw steps. Starting with 1. We're just going to add 1 to the previous each time. Library being the number of cards that are left in my library as I'm starting that draw step. So the first one will be the number of cards in my deck each draw step, I take one away. Okay. Now you notice I started at 1 with the 40 card deck. We are approaching this from the starting point of we've just shuffled up our deck, it's sitting in front of us, and we're about to start pulling cards off the top. So the first 7 draw steps represents our opening hand. And the nice thing about this approach then is that if you mulligan, the first 6 draw steps represents your new opening hand, and so on. And then depending whether you're on the play or the draw will determine which draw step corresponds with each turn. If you're on the play, the first 7 draw steps would represent your opening hand and turn 1, because you'd skip your draw step. And draw 8 would correspond to your turn 2 draw. If you were on the draw step 8 goes with your turn 1 draw. Okay, so we said we are interested in the probability that we are going to draw a land. So that's very simple. It's the number of lands in our deck divided by the number of lands left in our library divided by the number of cards left in our library. 43%. So when I shuffle up my 40 card deck with 17 lands in it, and I take the top one off the stack, there's a 43% chance it's a land. What about the second card off the pile? That's easy to determine if I know what happened in the first draw step. So if I know that I got a land, then I know there are 1 less, or 16 lands left, and 39 cards. If I know that I didn't get a land, then there are 17 left and 39 cards. So there's 2 possible events there. And then for the probability of either path, when you're looking at the probability of 2 events, it's the probability of the first event times the probability of the second event. So we would say 43% chance we got a land by this, and 1 minus 43, or 57% chance by this. Now the problem is that for each of these options is going to split out into 2 more options on whether or not that was a land, and each of those options is going to split out into 2 options on whether or not it's land. And the number of options we're looking at is going to grow exponentially. So that's not a practical approach here. Fortunately, we have a workaround. We are going to change the question just a little. We're going to tweak it and say, I'm not interested in whether or not I'm drawing a land, or in card A, I want to know if this is land number 1. By land number 1, I mean the first land that I draw this game. So for draw step number 1, it doesn't change anything. We still have our 40 card deck with 17 lands in it. There's a 17 over 40 chance that that's a land. But now looking at draw step 2, we're asking, what is the probability that my second draw is land number 1? And the importance of that is that means I haven't already drawn land number 1. So now I can take the probability that I haven't already drawn land number 1, which is 1 minus the probability that I have drawn land number 1, because we defined our deck to consist of only two things, lands and not lands. So if there's a 43% chance that I have drawn land number 1, the remainder, 57%, is the chance that I have not drawn land number 1. So for draw number 2 to be land number 1, we're looking at two events happening. One, that we have not already drawn land number 1, multiplied by the probability that we now draw land number 1, which is 17 lands left in our deck divided by 39 cards left in our deck. So there's a 25% chance that draw number 2 is land number 1. That doesn't include the chance that draw number 2 is land number 2, right? We could have gotten land number 1 on turn number 1, which means that we could then possibly get land number 2 on draw number 2. But that's not what we're looking at here. We will get to that momentarily. Here we're looking only at land number 1, and the probability is going to drop off each time because we can only draw the first land of the game once in the game. Once we draw it, we no longer have any chance of drawing land number 1. And there's a 43% chance that we get that land number 1 on our very first draw, which means that for the 39 other draws of the game, they're all sharing the remainder of that 57% chance, right? Draw number 1's taking its share of the chances of 43%, and the remainder of the draws have to share all that's left. And of that, what's that left there, draw number 2 has a 25% chance. So we can continue and say, what is the probability that draw number 3 is land number 1? Now we're looking at two events. We need to first not have already drawn land number 1 on any previous turn. So that's the probability that we have already drawn land number 1 on a previous turn is the probability that we've drawn land number 1 on draw 1 or draw 2. And when we're dealing with an OR case, we're going to take these probabilities and add them together. 43. There's a 68% chance that we have already drawn land number 1. There's a 43% chance that we drew it on draw 1. There's a 25% chance that we drew it on draw 2. So by the time we get to draw 3, there's a 68% chance that we have already drawn land number 1 this game, which means now we take 1 minus 68 So there's a 32% chance that we have not already drawn land number 1. And we multiply that by 17 lands left in our deck divided by the 38 cards left in our deck. 15%. Now, this is going to take a long time if we have to try to go through this and do this one by one. So I was doing that for the purpose of explaining. Now we're going to build a formula that we can just copy down through the rest of this and move on. So for draw 4, we're going to repeat the same process of draw 3. The chances that we've already drawn land number 1 is a chance that we've drawn it on draw 1 or draw 2 or draw 3. So we want to add all of these together, and we can use the sum function to do that. There's an 82% chance that we have already drawn land number 1 by the time we get to draw 4. And we're subtracting that from 1, giving us an 18% chance that we have not already drawn land number 1, multiplied by 17 cards, 17 lands over 37 cards. I'm actually just going to scoot that over to be in line here. Now I said I want to be able to copy that, and in Excel, if you have a cell reference that you don't want to move, you can put a $sign in on either the row or the column or both and lock that part of the cell reference. So as I'm dragging this down, I want the top of the sum range to stay on this cell, and I want the 17 lands to stay on that cell, and for my needs later, I want the number of cards in my library to stay in this column. So if I don't lock the cells and I just drag this down, you see now this is no longer looking at my number of lands. I've copied this down a row, and it moved this reference down a row, and it moved this reference down a row. That's not what I want. I want to tell it keep this sum reference in row 6. I only want to lock the row, so I'm only putting the $sign before the 6, because in the next step when I start copying this over rows to the right, I want this column to move over to the right. So I'm not locking that. See, I'm not locking the bottom of my sum range because I want that to keep moving down. I want number of lands to stay on that row, and I want number of cards in my library to stay in this column. Now when I drag that down, you can see that's still pointing at lands. This is still at the top there. This wouldn't have moved because I haven't moved to the right yet. But now I can take this and I can just drag it all the way down. And just for convenience, I'm actually going to drag it up to there. Just keep my formulas the same. If you're going to do that, be careful not to drag it over draw 1, land 1, because that was a slightly different formula. Being the first draw of the game, we didn't have that other term in there. Now, if we take the odds of drawing land number 1 on all these given terms and we add them all up, we should come up with 100% chance that if we draw through our entire library, we will eventually draw land number 1. And we see that's true. Some of these zeros are not really zeros. They're very small numbers. But when we get down to draw 24, we have 25. That is truly zero. Yeah, because there is some minuscule probability that I shuffled my deck up and I had 23 lands, 23 spells sitting on top of 17 lands. So it is possible that I go through all my first 23 spells before I draw land number 1. But I don't care about those decimals right now. So all we've really accomplished here, looking at land number 1, is shown that we are probably drawing land number 1 in our opening hand, our first 7 cards, which is nice to know, but not really that useful to us. Now let's look at drawing land number 2. Land number 2 means I have already drawn land number 1. So the number of lands left in my deck is 1 less. What is the probability that I draw land number 2 on draw number 1? The answer is 0. It is impossible for me to draw my second land on my first draw. So what is the probability that I draw land number 2 on draw number 2? For this to happen, I need 2 things to happen. I need to have already drawn land number 1, and then I need to draw land number 2. So the odds that I have already drawn land number 1 is 43%. I said before there was a 43% chance that I draw land number 1 on draw number 1. And I'm multiplying this by 16 lands left in my deck divided by 39 cards left. Now if you remember before, when we were looking at this and just saying what are the odds of drawing a land on draw 2, we were getting numbers that were in the low 40%. And if we add these up, we're coming up with 42. So if we're just saying what are the odds that I draw a land on draw 2, and I don't care what land it is, I'd say what's the probability of drawing land number 1 on draw 2 or drawing land 2 on draw 2. And again, when we hear that or, we should think adding these odds together. Now there is one last complication as we go to drawing land 2 on draw 3, and then that is as complicated as this gets, and we can just copy and paste out the rest of the chart. So when we're looking at the odds of drawing land number 2 on draw number 3, we now need 3 events to happen. 1, we need to have already drawn land number 1 before we can draw land number 2. 2, we need to have not already drawn land number 2, because like land number 1, I can only draw my second land once in the game. And then of course we need to draw land number 2. So the odds that I've already drawn land number 1, again, is a sum of the odds that I've drawn land number 1 on a previous turn. There's our 68% again. There was a 43% chance I draw land number 1 on turn 1, 25% chance I draw land number 1 on draw 2. So there's a 68% chance I draw land number 1 on draw 1 or draw 2. So 68% chance that I have already drawn land number 1, multiplied by the chance that I have not already drawn land number 2. So we're taking 1 minus the sum of the previous turns. Okay, so just looking at these terms, the sum of drawing land number 2 on a previous turn, which was 17%. There was a 17% chance that I drew land 2 on draw 2, 0% on draw 1. So draw 1, 0, or draw 2, 17, 0 plus 17. There was a 17% chance that I have not, 17% chance that I have already drawn land number 2. So 1 minus that, 1 minus 17, 83% chance that I have not already drawn land number 2. And we had 68 times 83. Okay, there's our 56. So we said over 3 terms. Those were the first 2. The last one, of course, was that I now draw land number 2. So there's 16 lands left in my pile, 38 cards left, 23%. So you can take note here, for land 1, it started high and consistently just went down. For other turns, we are going to get more of that bell-shaped curve when we eventually graph this out. I need to lock my cell references again. The top of each sum range, this row with the lands, and the column. And now I can drag that all the way down to make my formulas clean. I'm going to replace this 17. Comes out the same number. Again, be careful not to copy your formula over this 0. It won't like it. That formula will confuse it. Don't do it. Again, if I add up the probability of drawing land number 2 on all of these draw steps, I should get 100%. If I draw through my entire deck, I know that I must each and every time eventually draw land number 2. And now I can just copy this entire row over. There's one less land number 3. Got confused by this. This needs to stay at 0. So, land number 3. I know I can't draw land number 3 on draw number 1. I can't draw land number 3 on draw number 2. There is a chance I could draw land number 3 on draw 3. It's not a high chance, and so on. And I can copy this out for all 17 of my lands. You see, it got a little confused there. What that is just this row, because this was just a number I put in at 0. When I copy it over, Excel likes to add 1 to it. And I just need to take this 0, copy across that for all the rows. And now I have a table that will show me for each of my lands the probability of getting that land on a given draw step. Now, I did this for 17 because I had 17 lands. If you were doing a 60 card deck and you had more lands, you had 24 lands or whatever, you'd want to put those correct numbers in there, and you might need more columns. If you were doing, like we said, Angel of Thune or not Angel of Thune, right? This would be your angel, and say you had 4 of them in your constructed deck. Your 60 card deck was 4 Angels of Thune and 56 cards that are not Angel of Thune. Then only these first 4 rows would be relevant to you, because there'd only be 4 of them in your deck. There you have it. I'm going to end this video here, but next time we look at this, we're going to be looking at what you can start to do with this table. This is Drawing on Probability. I hope this has been helpful and interesting to you, and I will see you next time.